Good day, ladies and gentlemen. Welcome back to Emoji Economics YouTube channel. Yeah, so we have to talk about group data today. We need to look at how to measure the mean, median, and mode of a group data. And in this lesson, also be looking at the concept of assumed mean. All right, how can we use an assumed mean to get the true mean of a given data set? So that's about about the introduction. So yeah, why do we use a group data? Why do we group data? Or why do we group a data? Right? You understand. So the reason why we do that is in case the data is very large. So if you have a lot of observations, so it is just great for you to just like classify some of those observations together for you to make good sense of the data set. So imagine that you interviewed 1,000 people, and then so you're now say 1, 2, 3, 4, 5, 6, 7, 8 up to 1,000. So it's not just better to just do something like 0 to 100, no, 1 to 100, 101 to 200, 201 to 300, something like that, like a class interval like that, right? And then the results, your result is still going to be like the same, right? To your result is going to be the same compared to if you had not grouped the data set. But why go through all of that stress when you can do this in an easier way? Okay, so that's the essence, okay, of grouping data. So data it may have a lot of data. Um, I think then most of the values collected may be different. And the data may be spread over a wide range. Anyways, the most important one there is that the data may be too large, to use independently. So how then do we look for the mean of a group data? Right. So the mean, remember the formula of the mean is summation of fx over n, or the summation of f. So we need to get the sum of all of this. 2 plus 3 is 5, 10, 18. So we have 18 here. 5 plus 8 is 13. Then 13 plus 3 is 16 plus 2. Then that is 18. So it's chicken measured in kilograms. So people bought chicken. So those that bought between 0 kg, those that didn't buy at all, to 3 kg, you have 2 of them. People that bought between 4 kg of chicken to 7 kg of chicken, you have 3 of them, on and on like that. So yeah, remember that the observation itself, the sum of if this were not a group data, would have been like 0, 1, 2, 3, 4, then we add all of those to get our x, right? Is that what we do? No, that's what I mean. Like 1, 2, 3, 4. That was not what I meant to say though. 1, 2, 3, 4, 5, so multiply by your f, and then you get the fx. But in this case, it is grouped. So what exactly do we do? X in a group data is the midpoint. And thankfully we've discussed midpoint before, so just call it x, the midpoint. So how do we get that? 0 plus 3 divided by 2, remember, right? So 3 divided by 2 is 1.5, right? 4 plus 7 is 11. 11 divided by 2, that's going to give us 5.5. So what's the difference? The difference is 4, so just continue. 9.5, 13.5, 17.5. Okay, how else can you quickly know? 0 to 3 divided by 2, that's 1.5. Then how many numbers do you have in this interval? 0, 1, 2, 3. 0 first, 1, 2, 3. So 4 numbers. So just add 4 to the midpoint that you got. I'll be getting the successive midpoint. So then we have to find our fx. When we're treating sigma notations, right? We went through something like this. So sum of fx, so 2 times this is 3, 3 times 5.5, 11, 16.5, 16.5, and 8 times this 72, that's looking like a 76 to me. Where is it? So this is 76. 13 times 3 is 39, then 0.5 times 3 is 1.5, so 40.5. 17.5 times 2, that should be a 35. So let me quickly verify. Okay, yeah, that's it. So it is this sum that we are now going to look for. So we add up everything. 3 plus 16.5 is going to give us 19.5. 19.5 plus 76 plus this plus this plus this. Anyways, our answer is going to give us 171. Alright, so which means that the mean is equal to 171 divided by 18. 171 divided by 18, we get a 9.5. So the mean of this data is 9.5. So we're done, right? B, how do we get the mode? How do we get the mode? Okay, the formula for getting the mode is lower class boundary. Li is lower class boundary plus frequency of the modal class minus the frequency before it divided by frequency of the modal class minus the frequency before it uh, plus frequency of the modal class minus the frequency after it. So again, how do we get the mode? Look at multiply by really multiply. Yeah, there's supposed to be multiply there. Where is it? Mode. Multiply by C, which is the class size. Remember what the class size is. So the class size here is 4. 0, 1, 2, 3, 4. Then 4, 5, 6, 7, 8, 9, 10, 11. Right, so the class size is 4. Alright, so the frequency of the modal class. Now, here, you're not going to get a negative number. Why? Because the frequency of the modal class is going to be the highest frequency anyways. Do you understand? You're looking for the mode. Now, the reason why we can't just look at this and say, where's the highest frequency? 8. And then, okay, between 8 and 11 now, like, what exactly is the mode? So, which is why we can't just stop at, just picking a frequency and then saying that the mode is between 8 and 11. The mode is a particular number. So, what is that number? Okay, now, after that, this is the lower class boundary of the modal class, right? So, how do we get the class boundary? That should not be a difficult thing. Do I need to write that one out? What's going to be the modal class? The modal class is where the frequency is the highest, 8. So, what will be the lower class boundary? That will be 7.5. That should not be an issue for anybody now. I don't want to write it again. So, 7.5. So, our mode is going to be equal to 7.5 plus frequency of the modal class, 8 minus frequency before it. So, 8 minus 3. 8 minus 3 divided by 8 minus 3, then plus 8, the number after it happens to be 3 too. So it is just like that in this situation, please. It is not always like that. Then multiply by 4. So 7.5 plus 5 over, this is looking like 10 to me, 10, multiply by 4. 5 over 10 is half. Half times 4 is 2. 2 plus 7.5 is 9.5. So in this situation, it's happened that our mode is same as our mean. So it just happens to be like that. Our mode is same as our mean. So the next one is to find our median, right? So the formula for median, I don't know. I don't want to kind of erase this thing. Okay, let me just do this here. I think median's formula is lower class boundary of the median class, right? Plus n over 2 minus cumulative frequency before the median class, everything divided by the frequency of the median class, then multiplied by class size. So lower class boundary of the median class into opening a bracket, n over 2, that's sum of the frequency over 2, minus cumulative frequency before the median class over frequency of the median class. So which means that we need cumulative frequency to get the median, right? So CF, frequency is 2, 2 plus 3 is 5, 5 plus 8 is 13, 13 plus 3 is 16, 16 plus 2 is 18. Alright, so how do we know the median class? Median is that number that divides a data set into 2 equal halves, right? So we first do n over 2, which is 18. So you have 18. So n over 2 equals 18 over 2 equals 9. Alright, so when you check your cumulative frequency, where would you find 9? Alright, 9 is more than 2, 9 is more than 5, 9 is around here, right? Is around here. So the ninth number is around here. So the n over 2 there is not saying like just now, it's just talking about the ninth number. So 2, 5, ninth number is, so that means this is 2, 5, this like oh my God, okay. The first two numbers are between 0 and 3. The next three numbers are between this and this. So the next 8 numbers now will be between 8 and 11. So definitely the ninth number falls between 8 and 11. The first 5 numbers fall between 0 to 7. Or here, from the 5th number to the 13th number is within this class interval. Since we are looking for the ninth number is definitely between the 6th number to the 13th number. So I hope that is not difficult to like know. So that's how we come to this side and then check 8. So what's going to be the lower class boundary here? The lower class boundary. Remember that I subtract 0.5 from it. The lower class boundary is going to be 7.5. This guy is giving up on me. So 7.5 plus, this is 9, minus cumulative frequency before the median class. CF before the median class is 5, minus 5 over frequency of the median class, that is 8, and multiplied by class size is 4. So 7.5 plus 4 over 8 multiplied by 4. So of course you know the maths. 7.5, you do multiplication first, BOD mass. Alright, so this half times 4, which is 2, and this is also equal to 9.5. So in this particular for this particular data set, right, our mean happens to be equal to our median, happens to be equal to our mode. So what is the implication of that? It's this data set is normally distributed. So the kilogram of chicken bought by 18 people is normally distributed. So the data set showing the kilogram of chicken bought by 18 people is normally distributed, right? Or is symmetrical. We've spoken about things like that. And then if we were to draw the frequency polygon, so if we were to draw the frequency polygon, remember frequency is here, and then midpoint is what we used to draw here. Alright, so this is 0. So we start from, we are going, the frequency is going from what to what now? 2 to just, okay, 2 to 8. 2 to 8. You can just do 2, 4, 6, and then an 8. So here, 1.5, 5.5, etc. So we have I go to 17.5, 1, 2, 3, 4, 5. Anyway, so this can be 1.5, 4.5, 9.5, 13.5, 17.5, on and on. So 1.5 has where is it? Frequency of 2. So that one is here. 4 to what is this? 5.5 is the frequency of 3. How do you have this is meant to be 5.5? So 5.5 has a frequency of 3. 3 is maybe around here. 9.5 has a frequency of 8. Here. Oops, not bad. Then 13.5 has a frequency of 3. And then 17.5 has a frequency of 2. It's 2 supposed to be this high, 3 is here. Something like that. So even let's just extend it. Alright, so you can see it's a normal distribution. So this number here happens to be the mean, mode, the median. Additionally, I wanted to show this in this particular class so that you can see how the whole thing works. So now that we're done with this, let us talk about the concept of assumed mean, and then we move on from there to something else. So how exactly do we find the mean, the true mean? If the data is so large that we had to use an assumed mean, all right, so how do we find that? There's a relationship between the assumed mean and the true mean, and that relationship is this. The true mean is equal to the assumed mean plus sum of f times the deviation of x from the assumed mean, right, and divided by n. So how does that work? We want to like give ourselves an arbitrary mean. So we just say, okay, let's assume that a equals 6. Of course, remember that 9.5 was our true mean. So a equals 6. So how then do we find our true mean if a equals 6? Now, d is x minus a. So x minus a is d. So x, the values of x, 1.5 minus a. Do you understand? So 1.5 minus 6 is going to give us minus 4.5. 5.5 minus 6 minus 0.5. 9.5 minus 6, 3.5. 13.5 minus 6, 7.5. 17.5 minus 6, 10.5. No, 17.5 minus 6, 11.5. So then let me just cross check all of those. 4.5 minus 3.5, blah blah blah, 7.5. Exactly. Now remember that x minus a is d, right? So we just do the next one is fd. Like this, d equals x minus a. So I don't want to write f multiplied by x minus a again. So fd is going to be equal to 2 times minus 4.5 is minus 9. 3 times minus 0.5 is minus 1.5. 8 times 3 is 24. 8 times half is 4. That will be 28. 28. 22.5. 23 times 11, 22 times half 1, 23. So this is the one that we are summing. So when you sum everything here, minus 5 minus 1, that's minus 10.5 plus 28, on and on and on, we should be getting 63. So try the calculator. Minus 9 minus 1, that's minus 10.5. Minus 10.5 plus 28 is same as 28 minus 10.5. That should be, it's not 70.5. 28 minus that's 70.5. 70.5 plus 20.5, that should be 40. 40 plus 23 is 63. So here we've gotten that. So let's now use our formula. So our x is going to be equal to 6 plus 63 divided by n. N is 18. So by x equal to 6 plus 3.5. That's going to be equal to 9.5. And try it out. 18 times 3 is 54. Then 18 times half is 9. 54 plus 9 is 63. Alright, so 3.5 is correct. So yeah, so 3.5 is correct. So our mean is 9.5. So you can see that's how to use your assumed mean. If you want to, if you don't know the true mean, if you are given an assumed mean, so how do you get the true mean from it? So there's also a second formula here, which is by x equals a plus c sum of f over n. Now c is your class size, so you use this formula when the class size is equal to something like this. Our class size is like 4 all through, right? So there's a relationship between d and something else. D equals c of u, right? So this is the class size. This is our deviation. So when we do our deviation, when we divide u now, equals our deviation divided by c, or c equals our deviation, divided by u. So when do we, apply this formula? Because of course you need to get your u, and since you know that your u is your deviation, right, minus your class size. So let's even try that, d over c. So let's say we have a d over c. You would, for future classes, you need to like remember this. When we start talking about moments, curtoises, and all of that, so you need to like remember this. So D over C, let's check how it works. Is it D over C that I'm supposed to do it? Okay, yeah, D over C. So deviation divided by the class size. I didn't even solve it. Okay, you can try that out. What's the deviation? Minus 4.5 divided by 4, minus 0.5 divided by 4, minus 3.5 divided by 4, on and on. Just do it till the very end, right? And when you're done, come back here at x equals a6 plus your class interval is 4, right? Whatever sum you get, when you're done with this, you also have to create the column for f d over c. So otherwise, like this is, another name for this is just your u. This is going to be your fu. So do your d over class interval. Class interval is 4, just division over 4. Fill it. This guy, fill it. So you sum up everything that you have here, right? You're going to get a number. So that number multiplied by 4 must give you 63 back if what you've done is correct, and divided by 18, and still gets what you're supposed to get at the end of the day. So we just need this relationship in future classes to like work on it, finish it. So that's going to be your first assignment in this particular for this particular question. Should I even still give you another assignment? Let me give you a second data that I can actually really work with. So the assignments on the board: salary and number of earners, 90 to 100 down to 30 to 39. Then you have your different numbers. 90 to 100 is 9, 80 to 89 is 32, 70 to 79 is 43, 69 is 21, 50 to 59 is 11, 40 to 49 is 3, 30 to 39 is 1. So here you are these values are in thousands though, so I want to take note of that. And the values are in thousands. So using an assuming of 1000, like I don't mean 1000, like just 1000. Using an assuming of 1000, find the mean, median, and the modal salary. Then using a frequency polygon, comment on the normality of the distribution. So is it going to be a normal distribution? Is it positively skewed? Is it negatively skewed? That's what the question is asking you to do. So yeah, I think that's going to be all for now on the measures of central tendency. So in our next video, we're going to be talking about the measures of dispersion. Things that some of you already know, but there are some really, really nice things that are going to be learning afresh in our particular lesson. So see you there. Thank you very much for attending this. Bye.